Hi everyone, this video is for section 4.4, inequalities in two variables. So for part A, graphs of linear inequalities, we're going to first start with the question, determine whether the coordinate point 4, -5 is the solution of 3x plus 2y less than 4. So first off, what I would encourage you to do is please refer to the guided notes that I provided you for a brief review as to what each of the inequality symbols look like and what they each mean. In this case, I'll highlight this in purple, we're working with a strictly less than symbol. And as you can see in the guided notes, I've noted that the less than symbol looks like a bent capital L. So for this problem, we want to know if this coordinate point that we have is actually going to be an appropriate solution. And as we looked at in previous sections within section 3, what we can do is we can simply go ahead and substitute those values into their appropriate places. So since we have a coordinate for x and y, we'll go ahead and we'll take 4 and drop it in for x, and we will take that -5 and drop it in for y. So the result will be 3 times 4 plus 2 times -5 is less than 4. Essentially what we're going to want to do here is we want to clean up what's happening on the left-hand side. So from here, we'll do our multiplication, and we'll get 12, and then we have a positive 2 times a -5, so this is going to give us -10 less than 4. And from here, 12 minus 10 will give us 2 less than 4. The question that you want to ask yourself at this point is this a true statement? So honestly, take a step back, take a look at the inequality that you've built, and ask yourself, is 2 less than 4? And hopefully we're saying, yep, that checks out. But we also want to investigate what other solutions are there, because since we're working with an inequality, inequalities are kind of, I guess, wishy-washy in a sense. We just really need to make it so that we're going to pick some sort of coordinate point so that we end up getting a number that is less than 4 on the left side of the inequality. So we need to dive a little bit deeper, and in order for us to kind of learn a little bit more about this, we're going to go ahead and we're going to graph this situation out. So bear with me as I go ahead and sketch in a coordinate plane. Okay, so I'm going to go ahead and bring down our inequality. And what I would say here is, let's go ahead and actually graph this. So go ahead and graph it as if it were an equation. So what you might want to do is manipulate that inequality so that it is in a slope-intercept form. So to begin, I might remove 3x from both sides of the inequality. And that's going to go ahead and leave me with 2y is less than -3x plus 4. Then I'll come through and clear out the 2 from the y, so division will undo the multiplication that's happening between those two. And then we are left with y is less than -3/2 x plus 2. So just by looking at this, again, I know that my y-intercept is going to start at 2, 0. And from here, I'm going to go down 3, and then to the right 2. And if you prefer, you can continue to go down 3 to the right 2. Or if you prefer, you can also go in reverse, so I could go up 3 instead, but then to the left 2. And in doing so, we can see that those points are still going to line up in a nice linear formation. Now here's what is different. So again, in this case, we're working with that less than symbol. Whenever you are working with something that is strictly less than or strictly greater than, so in other words, there is not, say, like another solid line underneath the inequality symbol, we're going to use a dotted line in order to create this point. Or sorry, in order to create this line. All right? So here's why. Say, for example, I work with the point, it looks like I have 2, -1 here. Let's say I plug that into my inequality. So if I put 3 times 2 for my x plus 2 times -1 for my y less than 4. If we go ahead and we clean this up, we'll get 6 plus a -2 is less than 4. And then 6 plus a -2 would give us 4. Take a look at this final statement. It's saying 4 is less than 4. Well, that's not true. 4 is equal to 4, and that would be good, but we can't have a statement that says 4 is less than 4. This is a false statement. So this is why we use a dotted line. We're basically saying that any points that form this line, we're not allowed to use. So we're going to use this kind of invisible looking, but still visible, at least to us, dotted line. All of our other solutions, though, they're somewhere here. Let me clear the point out so that we have a clear space to look at. So all of my solutions are either on this side, or all of my solutions are on this side of the line. So what we would go ahead and do is, I would suggest pick an easy point as your tester. So maybe in my case, I'm going to say, well, the origin seems to be free, so I'm going to work with that. It's just zeros. So what I will go ahead and do is, with my origin point, I'm going to go ahead and do 3 times 0 plus 2 times 0 is less than 4. 3 times 0 is 0, 2 times 0 is 0, and then again 0 plus 0 will also be 0. So again, we want to ask ourselves, is this inequality 0 less than 4, or 0 is less than 4? Is that true? And hopefully we're all in agreement that yes, it is. So that means that anything on the left side of this inequality, of this dashed line for our inequality, this is a solution. So in order to communicate that to a reader, we would go ahead and we would shade everything on the left side of this dotted line. If you're still not sure, let's go ahead and show an example of an incorrect one. So I'm saying, let's go ahead and pick a point on the right side and kind of show that we're gonna get false statements. So how about we pick, let's see, how about 3, 3, 3? So I'm looking at this point here. So if we work with point 3, 3, we'll go ahead and we'll plug it into our inequality. And we'll just clean it up, so we're testing it again. So we'll get 9 plus 6 is less than 4. And then we end up getting the statement that says 15 is less than 4. However, we would definitely say that's a false statement. So what I'm basically saying is any points that you select on the right side of this inequality is going to be a false statement. So we don't want to go over there and select any options. Anything on the right side, however, that I have shaded in this kind of neonish green, these are going to give us true statements. The beauty of this is that we only have to pick one point from one of the sides, plug it in, test it, and if we get a true statement, we shade. If not, then we're just going to hop over to the other side and shade that side. All right, everyone, go ahead and continue to video 2 for some follow-up examples. What I would encourage you to do is try the problems in your guided notes first, and then watch the video to check your work.